Okay, so we are going to look at some equilibrium calculations in this video. So we're going to do a couple of end of chapter questions. So the first end of chapter question we're going to look at is number 33. So if you need to pause the video to obtain your book and pull up the questions, you may. So number 33, it tells me that I have my balanced chemical equation. It gives me the pressure of each reactant and the pressure of each product. And we are going to calculate the equilibrium constant. And so in this case, we're searching for K of P. So the P here is in regards to the fact that we're using gases. And so they're given to us in pressure instead of concentration. All right, so remember that K is going to be products. So I have NO, and the coefficient for NO is a 2, so it's raised to the second power. And the other product is O2, and its coefficient is a 1. And then the reactants on the bottom, so we have NO2, and its coefficient is a 2. So notice that we're using parentheses, no brackets here, and that's because, again, the values have units of pressure, not molarity, so not concentration. All right, so NO has a pressure of 6.5 times 10 to the negative 5th atmospheres. And we're going to square that. And O2 is 4.5 times 10 to the negative 5th. And my reactant has a pressure of 0.55 atmospheres. And that's going to be squared. All right, so if you want to pause the video here and plug and chug out an answer. Okay, now in terms of K, the equilibrium constant, never has units, so it's just a number with correct sig figs. So it looks like I'm supposed to just have 2 sig figs in my answer. So you should have 6.3 times 10 to the negative 13th as your answer. Okay, so that's a problem in which we are solving for K. Let's look for a second problem. So the next one we're going to do is number 67. All right. So in number 67, they actually give me the value of K. And we are to determine the total pressure of the container. So I actually need the pressure of ammonia and the pressure of carbon dioxide. So again, we're talking pressure, so we're going to use Kp. It's going to be the products, so NH3, and its coefficient is a 2, and CO2, and its coefficient is a 1, over reactants. Now, a reminder about K never uses pure solids or pure liquids. So we're not going to use the NH4, OCO, and H2 in our K because it's a pure solid. All right, so we know the value of K is 2.9 times 10 to the negative 3rd. Okay, and so we're going to use X's here. So I have just one CO2, so we're going to make that X. And the coefficient for ammonia is 2, so we have 2X, and that'll be squared. All right, so if I reduce this down, we're going to square the 2 and square the X. and then multiply by x. So we're going to get 4x cubed. We're going to divide both sides by 4. So x cubed would be equal to 7.25 times 10 to the negative fourth. And we're going to take the cube root of both sides. So x is going to have 9.0 times 10 to the negative second atmospheres as the pressure. And we know that x is CO2. So now I know one component. Now remember, we're looking for this at some point, the total pressure, which would be the pressure of my ammonia and the pressure of my CO2. So I have the CO2. So we need to find NH3. And so this was 2x. So we're going to take 2 and multiply it by 9 times 10 to the negative second atmospheres. And we're going to get 1.8 times 10 to the negative first. And so we add these together. And if you don't like scientific notation form, we could write it in normal notation. Okay. And then we can clearly see we're only going to have 2 decimal places in our answer, and we're going to get 0.27 atmospheres. Okay, so we've looked at 2 problems, one in which we're solving for K, and the other one where we're looking for a variable within K.